Let's see what this is saying. It's got natural logs inside of natural logs inside of natural logs. I like that. So what's it asking for? It says find the domain of the function. Let's start with easier problem for a second, and then we'll come back to the other problem. Okay. Just make sure we all understand how to find the domain of a logarithm. What's the most important feature of a log graph? Would you say? The asymptote. The asymptote. It's a good one. Where is that asymptote at?
X equals y.
For an exponential, it's along the x-axis. For a logarithm, it must be along the y-axis. Right? Is that cool? Yeah. Because it's inverse. And then it goes like that. And this point, what's that point going to be?
Usually 0, 1. Or 1, 0.
1, 0. I like it. Because log of 1 for anything is going to be 0. Because what do you raise something to make it 1? 0 power. I like it. All right, how we doing so far? So it's really good to know the basic shape of graphs. Because now I know this guy's domain. In general, the domain of any log, really, domain is going to be what? What x's am I allowed to use?
0.
And what kind of thing I'm going to put on 0?
Non-inclusive.
Parentheses, because it's an asymptote there. Up to infinity. Good. So that means that the inside of any log has to be greater than 0. So that's another similarity it has with roots. It's not exactly the same. Roots are allowed to equal 0, even roots, right? But logarithms that can't even handle 0. Poor little dudes. So, if I had log base 7 of 3x minus 1, how would you figure out its domain? What must be true about the inside?
3x 1 is greater than 3.
Yes, it's got to be greater than 0. It's got to be greater than 0 because of this graph, right? The inside of this logs cannot handle inputs that are 0 or negative. So the inside of this must be greater than 0. And you solve that. So sort of like if I had square root of 3x minus 1, how would you find this guy's domain?
Greater than or equal to 0.
Yeah, this would be greater than or equal to 0. Right, so they're very similar. So the interior of any logarithm has to be greater than 0. So let's take a step back now. Let's take a look at this ugly monster here. So the inside of this guy has to be what?
1.
That's got to be greater than 0. Right? Start there. So ln of x has got to be greater than 0.
Okay.
Right? Okay. And when is that true? I mean, what is the natural log greater than 0?
At 0.
Yeah, after 1. Right? Okay. You guys kind of with me? What we're doing here? Now what's weird is I still have like a natural log inside of another natural log, right?
So you gotta cancel out some natural log.
Well, I can't. Well, you can. I mean, the easy way to do this is to then say, not the easy way, but let me see if you guys are cool with this. This is where things get interesting. If this was, let's just take a step back. If this was this, how could I rewrite that in exponential form? How do I rewrite that in exponential? The base is e to the 0 equals x. So it'll be 1. So I can do the same thing here. E to the 0.
Wait, why E? Why E?
What's the base of ln? E. Yeah. And to show you even more directly, let me just show you this, because this is important. It's going to come up every now and again. What I'm actually doing is I'm putting an E base on both sides. Same thing I did here. If I put an E base on both sides, what's e to the ln do? Cancel. So I get x equals e to the 0. So when I rewrite a logarithm, I'm actually doing this. I'm applying the base to both sides. I'm doing the same thing to both sides, so it's legal. So here, if I do e to this side, what happens here?
Cancel.
So I get ln x has to be greater than e to the 0, which is 1. How we doing so far? So the first step I took was just because any logarithm, its inside has to be greater than 0. Right? That's the first step I took. That's what got me started. Now to get this guy's domain, I have to solve this. So probably the most direct way to do this, the most mathematical way to do this, is just to start solving this. If e to both sides, I kill an ln, and then what? The next step?
Do it again.
Do it again. I got another ln to kill. So like if I have 2 square roots, I have to square it twice to kill both. Ooh, you like this problem, I can tell. No, give me more. The first step was just not even caring that it had all this weird shit inside. The inside of any logarithm has got to be greater than 0. That's what got me started. So it doesn't matter what the hell's in there. The first step is just write the inside greater than 0. Now you start to solve this, and it is kind of rewriting, but it's good to know exactly what we're doing mathematically when we rewrite a logarithm into an exponential form. We are actually applying the base to both sides. It's kind of cool. So that killed that, and then I have to kill this guy.
So x is greater than e?
X is greater than e to the first, which is e.
That's 2.71. So why is it when you do this, though, you only pay attention to the 2 instead of all 3?
This guy gets me started. This is fundamentally an ln of something. And how do I find its domain? I make the inside greater than 0, and I solve.
So is that kind of like saying the function ln? No.
Sort of. The whole idea is I can't start attacking anything until I have something to solve. And the domain of an ln, the inside has to be greater than 0. That's what I'm going to try to solve.
Okay.
And that's where it comes from. It comes from the idea of domain of log. Okay, so that's definitely a difficult problem. I want you just to be able to do something like that. Right, that's probably the most I'll kind of throw at you. You with me? But I like that problem because it's so freaky, and it gives me a chance to talk about what's really going on when we rewrite exponentials. So how would I rewrite log base 7 of x equals y?
7 to the
Yeah, it should be 7 to the y equals x, right?
Yes.
Well, if I apply 7 to the on both sides, 7 to the log base 7 cancels, I get x equals 7 to the y.
4. Yeah.
Yeah. No, wait a second. Sorry.
Is that the one where you have to rewrite it inversely?
Ooh, yeah, that's yummy. So, what we're going to do is basically what we did here many times. So now I'm starting with, if I want to find the inverse of, let me just jump to the chase. If I want to find the inverse of that, how do I do it?
Replace.
Yeah, change x and y, so I get ln of y is x. Now how do I start to solve this? E. And now we know. Now we know how to tackle it.
Yeah.
Even better. All right. I mean, you guys see this? So now you do this. Now this gets really neat.
Whoa.
So this will be right. So I get ln of y equals
E
to the x.
And drop another
Yeah.
E to the ln y equals e to the x.
Oh no.
E to the y equals e to the x.
In WebAssign, it throws another number in there with it.
Well, I like it even better. So if you're WebAssign, you just enjoy that you got that extra bonus.
And then when you say watch it, it does this. So you're like, what the hell do I do with the number?
Well, now, wait a minute. So what do you mean? They have like a 2 in here?
Yeah.
Actually, mine had an 8, but same.
So I had an 8 there, an 8 there, an 8 there, an 8 there, an 8 there. You just divide by 8 at the end.
Yeah.
But you wouldn't have got that on the test, right?
What I say?
Don't say that.
What I say? I said no. But it's good to see this again. The main reason I assigned this is just to see what you guys would do, and also gives me a chance to talk about this more directly. It shows you why I need to know that. Because if I have multiple things, it's easier to think about it as raising each side, a base to each side, instead of trying to rewrite each log. It gets you get lost a little bit if you try to do it that way.
Just a quick question. How did you get the X out and the Y in?
You just
Remember,
take
that step is the
inverse.
conceptual step of finding an inverse.
Oh, right.
So find the inverse, that's what I do. Yeah. So that's why I put that down line most of the time, is because I'm telling myself I'm not doing an algebraic thing here. I'm doing a conceptual thing.
I was thinking that was where you started, and I was trying to figure out how you got there.
No, that's yeah. Okay. Anything else you were saying?
86 and 90.
I like it. Sorry, I can't
I just
stop.
want to make sure I get it right. Yes.
Oh, okay. Yeah, this is just a plug and chug problem. So, and so the thing you got to realize about this, and this happens a lot with these kind of problems, because in chemistry, very often you want to know how long until I have it down to 30% radioactive or something, right? So you have to deal with percentages of amounts where you might not even know what the amount is, and you don't need to know what the amount is. So in this one, it tells me, let's see, the concentration in moles per liter. So if you're taking any chemistry, there's little moles are coming back at you. Concentration is negative 2,500 times the natural log of these things. And these things are the intensity of the incident light and the intensity of light that emerges. So it kind of makes sense the murkier some water is, if you shine a light on one side, less light's going to come out the other side, right? That's the definition of murky. So murky really, technically, is concentration of particulates in there. You kind of with me? So what makes water murky?
Grit. Solution.
Mud, grit, dirt, something, right?
Nastiness.
Okay. So it kind of makes sense that the concentration would somehow be directly related to the intensity of light that comes out. So this is the intensity of light that you're putting in. The little O normally means the original amount of something. And that's the intensity you see coming out the other side. So of course, the clearer the water, the more these should be equal to each other. With me? Mm-hmm. And of course, if I had perfectly clear water, these would be perfectly equal to each other. What's ln of 1? Zero.
Okay.
Look at that. She's so smart. You got calculators. Ln, any log base anything of 1. What do I raise a base to make it 1?
0.
Okay, we just said that earlier, so don't forget that. Any log of 1 is 0. Period. So if these are perfectly equal to each other, meaning I see the exact same amount of light coming out, that must mean the concentration is 0, which we just figured out. Ln of 1 is 0 times that is 0. Mm-hmm. And if you start putting stuff in there, the concentration is going to go up to match that, and I'm going to have less light coming out. So all they say here is, what if I see 70% of the light that I put in coming out? So what if I is 70% of IO? Which written more mathematically is
70 over 100.
0.70.
or 0.7.
Okay.
So just plug that in here. What beautiful thing happens if you plug that in there? The IOs cancel. And then you can just plug in your calculator. So you'll get C equals negative 2,500 ln of 0.7 IO over IO. Bam. There's your EIO. And then you just got to put in a natural log 0.7 times that and see what happens.
And there's nothing wrong with putting in 0.70 over 100. I mean, I know it's still the same thing.
What do you mean?
Not over 100, but over 100.
70 over 100.
70 over 100, that'd be fine.
Well, yeah.
Yeah. But we should
0.7 over 1, there.
0.7 over 1, sure, man. I like that. Okay, cool. How you guys doing? Is that decent? So that problem was nowhere near as hard as it looked. You do have to get a little used to this. And then I don't care what the original light was. If I know it's at 70% of what it was, that's all I really need to know because the IOs cancel. Who cares what it was to begin with? Okay.
74.4.
Sure. Okay. Sorry. At that point, that's kind of anticlimactic for me. I don't care what the number is saying. And then what was the other one you're talking about?
Number 70. 4.4.
So 70 and 4.4. We haven't fully finished talking about this yet. Oh yeah, but we can do this. Let's see if you guys are able to do this here. Okay, so in 70 and 4, they give me this equation. Biodiversity, the number of species in a fixed area A. This is the number of species in a fixed area A. Alright. So right now I got that. That's okay, yeah. Normally that's some kind of constant. Yeah, depending on the type of species in the habitat. So C and K are constants that depends on if you're on an island or in the desert or whatever, right? Obviously a certain area of desert is not probably going to have as much diversity as a certain area of rainforest, right? So it's the area of the land you're talking about. I want to solve for S. And I want to do better than just, I want to do a little something over here. What can I do over here? Rewrite. Okay, how can you do it? Do you have a rule? Do you have a property of logarithms that says what log of something plus k log of something is?
Yes.
No.
But if you
got the addition.
That's better. So that's why the first thing you do when you're trying to consolidate logarithms is you get all your coefficients the hell out the way, right? So if you can, what can this k do?
Go up.
It can go back up here. Remember that property? Where the power can come down, well, I can put it back up. Right? Great thing for math is it goes both ways. So log S. Now what can I do with log C plus log A to the K?
Multiplying.
Good. Plus, when we add powers, I must have been multiplying the arguments. And so what really nice thing happens here? What's the base on this thing I'm using?
10.
Good. It's a common logarithm, understood to be base 10, just like a square root has an understood 2 in it. Same exact reasoning.
So multiply both by 10, divide.
You don't multiply them both by 10.
Put them to 10.
And you definitely don't divide by a log. Right? That's like trying to solve this equation going, well, let me just divide by square root symbol. So the answer is 7 divided by square root symbol. You figured it out. I saw the equation. Shit. You do something.
Alright, what's the proper term for doing it?
Raise both sides. Raise 10 to both sides. Right? Because that would be the inverse function of log base 10. Right? It's just like the E and ln we were doing earlier. That's how you kill logarithms. And really, another way to look at it is, what's the only way that log of this could equal log of that? If this
Equal
that. And that's what's going to happen here, isn't it?
Yeah.
S must be CA to the K.
So we
Yes,
found
sir.
out now.
On the right side, there's 2 log functions if you distribute the log to the C and the A. So how can you just cancel it out with one?
No distribution here. This is not times. Definitely not.
Isn't it kind of like
that's
If I have square root of x plus 4, this is not equal to square root of x plus square root of 4. I can't distribute the square root sign. This whole thing is inside this function, right? So this is the log of this. But there's a property of logarithms, because logs are powers. That if I have a log of a product, that's the sum of the logs. Because what I do when I multiply things, I add their powers. That is a property of logarithms. So this is not anything to do with distribution. This is a property of the logarithm function. Function.
So to cancel logs out, you use the base 10?
Yes.
Okay.
I'm not dividing. If you did, and you didn't show me, I wouldn't know that you did something completely wrong. But it comes out looking like it's right. But you cannot divide by log.
So it's just basically remembering what cancels what and using that to...
That's the whole point. Whenever we learn, and we're going to learn a lot of new functions this semester. We're going to learn trig functions like crazy. The minute we learn a trig function, or a series of trig functions, we have to then learn their inverse trig functions so that we're able to solve equations with them in it. If I didn't learn the opposite of a function, I could never do much with it, really. Alright, that's part A. What does B say? B probably just says plug some stuff in.
Yes.
Okay.
If K is 3, then doubling the area increases the number of species eightfold. I like that. If K is 3, and I have an area of A, my species would be CA to the third, right?
Yeah,
Now how do I demonstrate doubling the area?
2A.
Yeah, so now I make my new A twice the old A and just plug that in and see what you get. You should get 8 times somehow, right? Of course, because 2 cubed is 8. Then you just got to show me. That's as much as I'll do. I've basically finished. I like it. So if you double the area you're looking at, you should multiply the species diversity by 8 times. It's crazy. They don't cite any sources, so I don't know how true that formula is, to be honest. I want to look it up now and see if it's true. Alright. I could have seen an arachnophobia in my head where they gas the tree and that'll fall down. That was a lot of diversity. Okay. Is there anything else from homework?
No.
Okay, alright. Let's see. So, to finish up section 4.4 real quick. We basically did a nice problem there. But what if I had, let's do a couple of quick examples. So this, I want you to rip this guy apart. Right? Break him up using laws of logs. Break this thing up.
That's pretty simple, actually.
You gotta be careful about one little thing. You guys see what I'm saying? I got products in there, I got quotients in there, I got rules for those, I got powers. I could write that root as a power. And I got rules for what happens to powers inside of logarithms, right? So I want you to apply all the rules and try to break this up into a series of separate log terms. Break this dude up.
Bless you.
While you guys are doing that, I'm going to pass out the practice test. Thursday. What's up? What state? What state do you think of?
I don't know.
California?
You say water.
I know.
And I only know one person.
I say
that says it
dollar.
like that.
Dollar.
Oh, I said dollar.
I said dollar.
When I'm tired, I sound like Mary Queen. Or I go with that and yeah.
Why did I answer the question?
Yeah, you notice that?
Was it Ohio?
No.
Pennsylvania?
No. The last day you would think.
Rhode Island.
Maine, yeah.
No, this has become a geography test. It's from Georgia, all right? So do this problem. What? It's born in Savannah, Georgia.
Really? Where'd you
When I go back home, my accent comes out.
Where'd you get the water?
I have no idea. I got it from. Oh,
Everybody that I know from Georgia, I've never heard anybody from there say water.
I got a mutt accent, believe me. Okay.
I don't know how to do this.
All right, guys. So let's see. What's a good first step?
God, I didn't even.
Good first step here is, like I said, how do we rewrite this as a power?
Let's get 3/4.
Now, the one thing you have to be careful about is the fact that both of these are on the bottom. So at the end, both of those terms should be negative. That's where people mess up. So the division bar is a good separator. So I can write this as log base 2 of this minus log base 2 of that. Now here's where people mess up. That will be a plus sign, but there's a negative in front of the whole thing, so the negative would distribute. You guys see what I'm saying? So what happens up here? What's the last thing I can do with that piece?
3/4 will come.
Yeah, 3/4 can come down. Now Now here this would be minus log base 2 of, what happens to this product? How can I break that up?
That's 2 of x plus.
Yeah, log base 2 of x plus log base 2 of y squared, right?
So why couldn't you just distribute the minus through?
I will next.
Oh,
Yeah. And to tell you honestly, the way I would do this is I would just only put minuses on both of these terms because I know they're on the bottom. Right? So I would just kind of break this up and not even worry about, I just put negatives on both terms. Yeah.
So why, when you started out, why is it wrong to do log 2 plus that other stuff?
What's up? Sorry?
Putting log 2 plus
Log 2 of what?
like your original term, log base 2.
Yeah.
Right there, and then
Yeah.
put plus, and then in parentheses, log w to the 3/4 minus log x y to the second.
Yeah, one too many logs, is what you're saying. But so yeah, so you could do you could certainly do log base 2 w to 3/4 minus log base 2 of x minus log base 2 of y squared. That's what I would do. Yeah.
Okay.
I want to show you technically why they're both negative, but then the shortcut is, of course, they both have to be negative. They're both on the bottom. They're both being divided.
Yeah.
So they both should represent the division rule, which means they both should be subtracted. Okay, how we go so far? So there's 2 reasons why that's true. And then really the last couple things I could do, like I said, is distribute that negative. And what can I do here?
Bring the 2 down.
Bring the 2 down. Cool. So sometimes you want to be able to break them apart, because maybe parts of those cancel with other parts somewhere else. But more often what you want to do is the reverse of this. You want to slap those things back together, and that normally is a little bit easier to do. So let me give you one of those. So try this one. So I want you to do the opposite. I want you to recombine these into a single log. Of course, I'm allowed to combine all of these because they all have
the same base.
the same base. Cool. Just like you can't multiply roots unless they have the same root. What? See, that doesn't make any sense. Log base 2 by itself is sort of like a square root symbol with nothing in it. It doesn't make any sense by itself. So it's going to be log base 2 of w3 minus. Yeah, that's fine. Basically, it's the same thing as this, but you had an extra log or
I
something.
just took it out.
Oh, you can't. This is not multiplied.
Right, you're adding from the front. From the top.
So right here, this is not log 2 times this, so I can't take a log 2 out or something.
Okay, because up there it's log 2 plus that minus log.
There's no plus there.
No, I mean because it's multiplication. So that
Under here.
Yeah.
Right, okay. So it'd be log 2 of x plus log 2 of y squared.
So you're not multiplying log 2 to the
No,
fourth root?
No, it'll never multiply. It's inside the log. It's not multiplied by the log. So it's the same mistake, people when they first learn functions, they do some work and they get f of 2 equals 7, and somehow they go one more step and they get f equals 7 halves.
Okay.
That doesn't make any damn sense. These aren't multiplying. 2 is inside f.
Okay.
Yeah.
Does that look right? Thank you.
Yeah. And the only mistake is since it's a positive, it should multiply by what this is. So it's over 1, so it should be on top.
Oh.
So how are we gonna, what's the first thing you can do?
Bring your A up.
All the coefficients can go up. I like it. And to tell you honestly, let me show you something. So let's see if I want to do this. You could bring the negative 2/3 up. And then be plus that to the negative 2/3. And then what would happen with the negative 2/3? It would go down, wouldn't it? So you actually could make all your logarithms always all positive. Just make all the negatives plus negative and then bring that up to the top. And then they're going to put themselves in the right place inside. I don't know if that makes any sense. If that doesn't make any sense, then you just be very careful. Become a 3. Okay. So now the mistake people make is they'll get this first part right. Y
To the A.
over that
Y to the A.
to the A. Where'd the A go, Jeff? That's better. And then, where do I put this though? It's got to be up top because it's multiplied by what this is. So only the one that's negative is going to end up on the bottom because it would be the only one with a negative power if I brought that up with it. Yeah.
Do you want us, like on a test, when you give us this, do you want us to put it like with the 2/3 power, or do you want us to put cube root of
No, you don't have to put
X
cube root.
Okay.
It's logs, so if you did, it won't be wrong.
Okay.
But you might as well keep them as powers
All right.
because that would make more sense. Yeah. So if they start off with the root, whoever the silly person was that did that, say, screw you, dude, let me put it as a power because that works better with logs.
So, wait, can you explain the flipping one more time? Just why they go into certain places?
So let me do this one thing at a time. So if I put the first two together, so far so good, right? Yeah. So let me just keep. I haven't done this one yet. That's what the first two together looks like. Now what do I do when I have log this plus log this? I take that times that.
Okay.
So of course it would go up top. So as if you're careful, you do it one step at a time, you'll see it. If you try to put everything together at once, all the positive terms go up top. All the ones that are being subtracted, all the logs being subtracted, their arguments go on the bottom.
And that's just a property, right? Negative
Exactly, because when I subtract logs, I divide by the argument. When I add logs, I multiply by the argument. Okay, and of course, there should be the 17 here. So, the reason we want to be able to do this, and now I'm getting into section 4.5.
You didn't finish 4.4 yet.
I know. We'll finish up 4.4 in a second. The reason we want to be able to do this is if I want to solve this equation here. Yeah, this is 4.5. We do have a couple things to finish in 4.4, but I immediately want to follow that with this so you see some motivation as to why we do this. Now, let me show you a little side note. Let me show you a really simple log equation that we did. Basically, we did it before. If I had that, how do I solve it? 4 to the negative 2 equals x. I just rewrite it. And actually, we know that we're really doing this. So I still get 4 to the negative 2 equals x, right? We've done that before. It's simple. So why is this more difficult?
Because now you combine them.
There's two terms. I just have to combine them. Let me be more careful there. Yes, sir.
Okay, so that's all in one line. You're not saying log 4 to x minus log.
Yeah, this is a log minus another log
Okay.
equals 2. Yeah. Good. So I'm going to rewrite the difference of these logs.
Log x
Log.
Yeah, log 4
x.
x over. Good. Now how do I rewrite this? 4 squared equals that business. And that should be really nice, right? How do you solve that? How do you solve that? Maybe it's not really nice.
By x minus 2.
Both sides.
Yeah, multiply by x minus 2. Simple, because one of your variables is down, so the first thing you do is get the hell up. Can't do shit with a variable on the bottom. And now this is nice, right?
Mm-hmm.
3 get 16x minus 32 equals x.
That's the
Plus 32.
15x equals 32.
Yeah.
Divided by 15. And now, much like roots, see, there's so many similarities, but they're not the same thing. Same as radicals. When I solve a radical equation, what do I have to do at the end?
Okay.
Check it to make sure it doesn't make any interiors negative. We're talking about real stuff here right now. So the same thing with logarithms. You can't make any of the insides 0 or negative. They all have to be positive.
Yeah.
So 32 divided by 15 is positive, so that dude's fine. 32 divided by 15 is it bigger or smaller than 2?
Bigger.
Bigger than 2, so that dude's fine, right? As long as it's positive. So that is a solution. So you will have extraneous solutions that you have to cross out. If that would have been 28 over 15, he would have freaked. I would have had to throw it out.
I'm just writing no solution for
You
that.
write no solution, just like you had with radical equations. So there are a lot of similarities between logs and radicals. They're not the same thing. Otherwise, why would we have both of them? And you're all like, because you're math people, you're weird like that. No. How you guys feeling with that? That's an immediate use for that skill. Being able to combine all the logarithms to a single log. Okay. So, let me show you the one last thing from section 4.4 because it's crazy useful. Unfortunately, I think if you look at your graphing calculators, what logs are you able to do?
Natural log, but
Unless you have a nice one.
If you have a nice one,
You can do a log base.
yeah. So they didn't used to be in there.
Yeah, where's that?
However,
one?
for those of us that don't have those,
Good. Yes. For those of us who doesn't have that, and in general, even if you have that, I don't give a shit. I still want to see this.
What are you talking about, log base?
Send them out.
Don't worry.
It's like-
I'm not going to tell you.
if you don't know, too bad.
Get a manual.
It didn't come with one.
Look, Google.
It should be on there.
Good Lord. All right.
We've got to do the log base formula.
Change your base. You couldn't do this, Jeff. Today? Every day. Okay, so if you have a calculator that does not have a log base x, meaning you can only do log 10 and ln, you want to know how to change the base. If you have a base 7, and you have no way to do base 7 in your calculator, you want to get an actual approximate answer, you have to have a way to change it into base 10 or base e. And there is a way to do it. It's crazy. So if I have...
Okay, I remember that.
If I have this, and that's why I wanted to do that, but I want to. Just remember another reason why I wanted to do this, and there was more than that, but oh well, we'll get it here. How do I kind of solve this for x? Raise both sides, raise what to both sides?
B.
B, because the base is b. So if I raise b to that, I get b to the y equals x. Is that cool? I'll let you guys absorb that. Just like the e thing we did earlier, and the other thing, I can't remember what it was, the base. Those are inverse functions, so they kill each other. Now I can apply a log to both sides that I actually know, because that property where the power comes down, it doesn't matter which log I use. I can use any log I want to. So I could use ln, which is what most math people use it because there's less letters in it, right? Like we said the other day. How do I solve for y now? So why did I do that? I'm trying to resolve for y, but I'm trying to not bring it back to the same thing it was before. So I'm going to apply a base that I know. ln or log base 10. So if I do ln to both sides, what can I do? This power can do what?
Y go down.
Y comes down.
Oh yeah, that's right. Divide by ln of b.
Divided by ln, sorry? Oh, no. So I'm trying to solve for y, right? So how do I get y by itself?
By dividing.
Divided by ln b. This is y times ln b. So I can divide by ln b. And know the ln's don't cancel, right? Square root of 7 over square root of 2 is not 7 over 2 because the square root symbols cancel. You can't do that. Same thing here, you can't cancel the ln's. But I want you to notice is, what was the base I used?
B.
So any base, right? So it's the ln of the inside over the ln of the base. The base goes on the bottom, the base is on the bottom. I'm trying to give you a way to remember this. Yes?
So you can divide by 1?
Of course, definitely.
It's only logs that you can divide.
No. All right. If I have log x equals 7, I can't divide by log. That makes no sense. If I have x times log 2 equals 7,
You can divide.
I have multiplication. So division will come in and kill that. Here I don't have multiplication. I have logification, right? I need anti-logification, otherwise known as 10 to the power, right? To kill it. You guys kind of with me? That's what I mean. You can't divide by a log on its own. But if I have x times something, I can divide by that something, whatever the hell it is. What is log 2?
Log 2.
Log 2.
It's a number. So I can divide by any number I want to, except 0, and I know it's not 0.
Log 2 is simple.
Okay. Freakiness. So here's the immediate usefulness. If you don't know or don't have a log of any base button, and even if you do, I don't care, I want you to do it this way. What's log base 11 of pi? Ooh, I like that. How can I rewrite that?
11 to the x.
Yeah, ln of
Pi
pi.
over ln 11.
So remember, this is a derivation of a rule I can use now. I don't have to do this whole thing every time. I can go straight from log base b of x, I can go straight to ln x over ln b. As long as the base is on the bottom and the argument's on the top, you're good.
Never mind, I totally just got that.
So try it. What's natural log of pi divided by natural log of 11?
0.47738
And be real careful when you plug it in. I think it does a parenthesis maybe. Be sure you close that bad boy, right? Or else it's going to have the whole damn thing inside it, ln. So what is it?
0.477.
38944.
0.477 blah blah blah. Okay. Yeah.
So you just took that and used it on that equation.
That rule and
Okay.
use it on this expression. Yes. Yeah.
It didn't have to be natural log, right?
Good. It could have been any log. So right here I could have done log. So here's the funny thing. I could also write this as log pi over log 11. Do that in your calculator. What's log pi over log 11? Same answer. The ratio of two logs is actually independent of what base you use. That's kind of neat. That is really what that showed me. That's a neat thing in itself. If it's a little too neat, don't worry about it. You don't have to know that. You just have to know the change of base formula, right? So if I had log base root of 7 of 1.2, how can I rewrite that?
Log 1.2 ln 1.
Yeah, I can do ln or log, it doesn't matter. ln 1.2 over ln root 7. And figure out what the hell it is, right? Kind of neat. So there are a lot of things that come out of it. The change of base formula itself is very simple to apply, but it has huge ramifications. It's just so neat that it doesn't matter what log you use, the ratio is the same. It's kind of cool. Okay. So what I meant to do earlier, and I totally forgot why I did that, was to kind of do what we just did, but more generally. How do I solve? We know how to solve logarithmic equations now, don't we? You combine your logs and you change it to exponential form like we did earlier. With the log base 4 problem earlier. Okay, I'll take that as a you remember. But how do I solve an equation like, just put something, 3.1 to the x equals 14.91. What's the problem with this equation? Where is my variable? So it's stuck somewhere. What's the only function we know of that we can apply that would unstick it?
Log.
Yeah, logarithm has a property where the powers come down. So now that I know logs exist, I can solve any exponential equation where a variable is stuck in the power. I couldn't solve this if I didn't have the inverse of an exponential, which is a log. So if I do ln of both sides, what can I do with it?
Bring it back to the front.
Yeah, so this will be x times ln 3.1 equals ln of 14.91.
Divide by your ln.
And divide by what you don't want. Exactly. This is x times this. So I saw earlier, I can divide by that number, whatever the hell it is. So this is the exact answer. And the approximation is anything you get from your calculator by plugging that in. People always get those confused. When I say exact answer, people think I mean give me a lot of decimal places. No, it's never exact. Because how long does it go?
Forever.
Forever. So if you want to be exact that way, you have to write every single number down like forever. Yeah.
Why did you use the natural log and not log? What's
Because
the difference?
one less letter.
Okay.
Truly. It's the only reason.
So does it make anything different? It doesn't change anything?
Doesn't change anything. That's what we were saying earlier. The
Okay.
ratio doesn't care what log you use.
Okay.
We use ln or a common log because that's what most of us have on our calculator to do. Some of us have any log base, and I don't care. Okay. What's the approximate answer?
2.388. Blah, 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 blah.
So to check your work, you could just do 3.12 answer and see if it equals 14.91.
Okay, so back on problem 70, when you were telling us we couldn't divide by a log, so could we, if that log C was there and then it brought that K up to the front, then you could divide by that log, right? It's like that's on here, it's just those two pieces, then you can divide by a log?
No. The logs would cancel because I could raise 10 to both sides. I can never divide by log. I cannot. I cannot divide by ln. I can divide by log of 7 because that's a number. So if I had x times square root of 2 equals 6, how do I solve that? Divide by root 2 because it's just a number, right?
Yeah.
But if I had square root of x equals 6, I can't solve that by dividing by square root symbol.
No, you got it.
The square.
Right, so
Square root of something, I can divide. Log or ln of something, that's a number. I can divide that all day. But I can't divide the actual log symbol. That doesn't make any sense.
Okay, so if there was numbers there, then we would have been able to divide.
Yes. So if I had s log 7, I could divide by log 7.
Fantastic.
Sweet. I knew we'd get there. Real quick. Obviously, if I would have done logs, this would have been the same thing, right? But what if I did log base 3? I'm sorry, log base 3.1. Now, why would that make sense? How do I rewrite this in logarithmic form? It would be log base 3.1 of
14.9
careful.
equals.
The power is the answer, right? So the input and the output switch because they're inverses of each other. Now this I could apply. Well, that's it. I would say ln of 14.91 over ln of,
3.1.
which is what we got
Oh,
there.
dang.
Yeah. I mean, the change base formula is really just a shortcut for what we did there. So if you want to start with the base they give you and then change it by changing the base, or if you just want to attack it with ln, which is actually what I do. Attack it with ln and just get it there directly. I don't care. As long as one of those two ways makes sense.
Was this still 4-5?
Yeah, this is 4-5. 4-5 is all about solving equations with these things in them. So here, I'm going to give you, we're going to look at a couple of easier equations. In fact, so easy we don't need logs for them. And then we're going to look at a couple of as difficult as they get for you equations.
Is that as far as we're going as 4-5? Is that it?
We're going to find out. Okay. So if I have this here. I don't need logarithms. I could use logarithms and they would get you the answer, but I don't need them. Why do I not need logs here? They have the same base. So of course 9 is 3 squared. 27 is
3.
so I get 3 to the 4x equals 3 to the third. So what must be true? Yeah, 4x must equal 3. So actually, to get from here to here, we did one of two things. We said the only way these could be equal is if these powers are equal. Because the bases are already equal, right? Or we did log base 3 of both sides. And that brought this down. You guys, either way you want to look at it, we get to the same place. If I do log base 3 of both sides, what happens? You beat that.
Okay.
Series of stupid sound effects. Oh, well, too bad. How do I solve for x? That's right. Okay. So when you can make the base the same, hell yeah. Right. It only makes sense. Using ln is not wrong, it's just you didn't need to. Maybe. So what about here? You guys try this one. Yeah, that's gross. Let's do that. Yummy. If you try to use logs on this problem, you would actually end up doing the hardest problem you could. So this one's definitely much better with making it the same base. Of course, what base are you guys using?
2.
Good. Oh no, it's supposed to stay. I don't know. Turn it in my head, who knows if it's right. So what's my, let me bring it up here. What's my first step here?
1/8.
Yeah, make everything in terms of 2, right? So this will be 2 to the
Negative third.
good? Equals 2 to the 4th. So you're just rewriting those, right? Completely legal, because those are both representations of that. Amen. And then here you get 2 to the...
Negative 3, yeah. 3 minus or plus 3x.
I got you. And then what do you get over there?
8x.
Oh, 8x plus 16.
Good. And then you know that
They have to be.
the powers have to be the same, so you get 3x minus 3 must be the same as 8x plus 16 in order for this to be true. Yeah, so you get negative 19/5. Okay, good. Yeah.
Should it be plus 3?
Why?
Because when you multiply...
Negative 3 times 1? Negative 3. And negative 3 times negative x? Positive 3. Cool. Right? Negative 3 times 1 is negative 3.
Oh,
Okay.
yeah.
No, the whole point of like showing the word in a sense on the 2 is to get rid of them. How do you, what would you, was it log based?
Oh, yeah,
So
yeah,
essentially
you're doing log base 2 at both sides here is what you're doing. That's one way, or the reason I don't show any work there is because
you already
it's
made the
completely, you can say the only way this could be true is if the powers are the same.
Yeah, but
But if you want, yeah, here you go. You've been human. So log base 2 for both sides is what we're really doing. Just kill that 2. And then you get x equals negative 19/5, right? Cool. Okay, not too bad. So here comes the worst problem you can do.
Oh
I thought somebody was going to say, and you're not going to give us anything, right?
no. You are.
I totally am. That was a silly question. Before I throw it at you, let me make sure they do something like it. Yes, right. Oh, sorry. Yes, they do something. So if I had 8 to the 2 plus 3x equals... And really, the reason this is gross, the reason people don't like this kind of problem is bookkeeping, just keeping track of what you got. That's it. That's what kills people on this problem. I'm not done with it yet, by the way.
So worried.
There, now I'm done. This is what makes it more difficult, is because they both have a power. I can't make the bases the same, right? Not very easily. So what do? Yeah, I've got to do ln. And when I do ln, this comes down. How are we doing so far? Is that good? So that's why we do ln, so the powers can come down. That's where my variables are. Now this is where people freak the hell out. I'm trying to solve for x. Where's x?
Both sides.
Both sides. So and in fact, what do you have to do first? What's the very first thing you do when you're solving equations?
You gotta go
Distribute.
minus.
Distribute.
Oh,
And so, dear God, do not put decimals. I'm going to want an exact answer and then an approximate answer. So there's even less reason to put a decimal here. But if you put a decimal here, you have to keep track of that the whole way through. Screw that shit. It's better to keep track of ln 8 instead of, whatever the hell, 2.4965. So I distribute this number through. That's just the number. So I get 2 ln 8 plus 3x ln 8. So what are you getting on the other side? 5x ln 11.1 minus ln 11.1. So what do you do if it looks like there's more than one thing you're trying to solve for? There really isn't. What do?
Combine.
You get them all on one side and then you can
Pull out the answer.
pull it out. It's really just one x that's been distributed. So you just have to get them all together so you can see what the hell it is. What am I saying? So I want to get all my x stuff on one side.
Right, so minus 3x.
Yeah, let me minus that way so this stuff will be positive here. Then I'm going to pull that over this way, right? Get my x stuff together, get the numbers on the other side. The same thing you've learned ever since you've started solving equations. So 2 ln 8 plus ln 11.1 equals 5x ln 11.1 minus 3x ln 8. I'm going to let you guys absorb. So all I did was subtract the 3x stuff and add the ln 11.1 stuff. Because now what can I do?
Pull the X out.
Pull the x out. Yeah. This would be x times. And then, of course,
Divide.
divide by the stuff you don't want.
That wasn't
That's the exact answer, right? X equals that. And if you want to put this in a calculator, you really have to be careful. Because you got to put the top in parentheses. And your calculator opens that, and you better close it. It opens that, you better close it. Same thing on the bottom. You guys with me? So it kills people on the next step when they want to try to write the approximate answers. They're not careful with the parentheses. They're not careful with the order operations in their calculator. It's not hard to mess up. There's so many freaking parentheses there, but you just got to keep track. So just try it out. Try to see what you get.
So then the approximation isn't going to be order of magnitude.
No, it still will be, totally. Yeah. I mean, if I tell you, this equation models energy from something, and x is the length of my wire, whatever, right? And I tell you, the wire has to be 2 ln 8 plus ln 11.1 divided by that feet. I mean, what the hell's that shit? Tell me 4.96 feet or something, right?
Yeah.
So I got to vote for 1.13?
Yeah.
Cool. I got several votes for 1.13. And of course,
Negative.
No.
Unless I did something wrong.
I don't think so.
Probably. Did something wrong.
No, yeah, this makes sense. These are really, really close to each other, right?
Yeah.
Relatively, right? I don't, if I square this, it's 64. So it's much closer to 8 to the first power than is 8 squared. You guys kind of with? So really, if I just look at when are these two equal, they would be equal at 3 halves, 1.5. So that makes sense. Should be close to that, right? They're not exactly the same, so they're not going to get the exact same answer. If you don't understand what the hell I just said, you could always, in your calculator, you do 8 to the 2 plus 3 times answer, and see if it equals 11.1 to the 5 times this minus 1. See if they're equal to each other. Yeah.
So when you say round to 3 decimal places, do you want us to round that third one up? Just,
So if I say round to 3, I want one more decimal place.
and it's 1.1327.
Okay, so
So do you want that 3 or just 2? Okay.
Yeah. Round it. Truly round it. Don't just truncate it. Yeah. All right, how are you feeling? Feel all right? Okay. Yes?
It's the same answer, but it was off by decimals. Is that fine?
Did you put this whole thing?
Plug the X back in.
Oh, yeah, sure. That's fine. Because if we use an approximation here, it's not going to be perfect. Yeah. Okay. Let's see. I was kind of planning on doing this anyway. I do want to talk a little bit about 4-6, but I'm going to make the, who knows what I'm about to say.
You're going to make the homework extra credit.
Yes, in this case, you're right. 4-6 is important, but it's just a lot to kind of cram in here at the end. I definitely want to get all this behind us because I want the next test. It's got to be totally focused on trigonometry. That's like our next chapter of this. I want nothing but trig.
That's a bad sign.
Huh? That's a bad sign. No. But in this section, you learn that. This equation, in general, models population growth. So I told you that E is really good at modeling growth. At talking about, put 2 rabbits in a room, give them food, not money, and see what happens. And if I put a negative sign here, that would be like the radioactive decay of materials, right? So this could also be used for continuously compounding money, stuff like that. This R is the percent of what is present that you have. So like population growth. I think it's like 1.4% population growth is supposed to be what you need to sustain a population. So if you have 2% population growth, what that means is if you wait a certain amount of time, you'll have 2% of your current population as babies. So your population grows by that much, right? You with me so far? So what's really beautiful about this base, the base E, is that number will directly relate physically to what's going on. If it's 2% growth, I'll see a 0.02 there. No other base would have that, right? They would still, I could still put a 3 there and have it work, but that wouldn't represent the rate. That would just be whatever number to make it work. I don't know if you can see what I'm saying. So if I use a base of E, that number is the actual rate of growth. So if your population is growing at a rate of 2%, there would be a 0.02 there. That's why E is such a beautiful base to use. It allows you to see what's going on. Maybe. And of course, E has in it the fact that nature grows on itself. So if I add people to my population, a little bit later, those new people will add new people of their own to our population, right? So not only will the original people be growing too, not themselves growing, but their families, their kids will later have kids of their own. And this is why population growth does follow an exponential curve. It's kind of neat, right? Hopefully we really need to make that level off until we can, find another planet to kind of spread to. Titan. Yes, Titan.
And then the T is just the time, I'm guessing.
T is time. Yeah. So let some time pass. What do you think N naught is? Initial population. That little subscript of 0 means initial. And this is the number. So this is like if you had bacteria in a petri dish, and they have a certain rate of growth. Very often you talk about their doubling time, and the inverse of that is the half-life. Not the game. But how long it takes it for half of them to still be there. So you talk about that with radioactive material too, right? The half-life. Talking about Chernobyl and the half-life and how long it's going to be before somebody can live there. It's crazy. So just make sure everybody heard me right. 4-6 is extra credit. It's a really good idea, though, if you're going further in mathematics to do it. I just feel bad rushing it at the end. Test is still Thursday. So tomorrow I have the answer key. Yes.
Okay, so I plugged that into my calculator,
Yeah.
and that is what I got, and I have no idea